In the previous video, we had discussed about the structural representation of organic compounds. That is, we talked about the structural formula, the condensed formula, as well as the bond line formula. In this video, we are doing the in-text questions. The first one, explain each of the following condensed formulas into their complete structural formula. So the structural formula will basically have all the atoms and their respective bonds. So for the first one, CH3, CH2, CO, CH2, CH3. So here we have carbon, we have hydrogen, we have oxygen. Now the reason we put double bond over here is because oxygen's valency is 2, which means it can form 2 bonds. Now had the same thing been CH2 OCH2, then we would have written it like CH3OCH3, we would have written hydrogen, 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 and we would have written the oxygen in between. But here it is CO, which means this oxygen is bound to the carbon atom, and oxygen can have 2 bonds, or the valency of oxygen is 2, so we've written it like this. This is the ketone group, actually. The second one, B, CH3, CH, double bond, CH. Now here it's given as CH2. There are three, three CH2 groups over here, which means there are 3 carbons. So CH2, 1, 2, and 3. In the end, you have a CH3. So let's just count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So here, if it's written as CH2 taken thrice, it means there are 3 CH2s in this molecule. And that has been represented over here. This is only CH2 taken thrice. The next one, for each of the following compounds, write the condensed formulas and the bond line formula. So condensed formula for this, the first one is OH. Now the number of CH2 groups are 1, 2 and 3. 3 CH2 groups are present in this molecule. So we can just write it as CH2, 3. Okay, and then you have CH, then you have CH3, and then you have another CH. Okay. CH, and then because this actually denotes, okay, so the reason you have a bracket over here, now let's take this carbon. This carbon is bound to a CH2 over here on the left. Okay, it's bound to a hydrogen, and it's bound to this CH carbon. This in bracket denotes that it is also bound to an alkyl group, or a methyl group rather. Okay, so this in essentiality means that it is bound to this methyl group. Now in this carbon's case, you have the, let's take suppose, okay, in this carbon's case, CH. Okay, we know it's bound to CH3. It is also bound to the other CH3. So we can combine these two and just write it as CH3 taken twice. Okay, so now its formula, the bond line formula would be 3 plus 1 plus 2. So 1, 2, 3, 4, 5 and 6 carbon atoms. So 1, 2, 3, 4, 5, 6. Perfect. Now the first one is not the alkyl or a methyl group, but it is an OH. So we have to write OH. Now first, second, third, fourth. The fourth carbon is bound to another CH3 group. So 1, 2, 3, 4 CH3. And we also know that this carbon is bound to 2 CH3 at 2 CH3 groups. So here it will again be written as CH3. So this is the bond line formula for this particular molecule. The next is NCCHOHCN. So I'm just erasing this here. Okay, so the condensed formula of this particular molecule is HOOH. Now this carbon atom is bound to two CN groups, so we will just write it as CN taken twice. The bond line formula for the same, you only have one carbon atom. Here you can write CN to denote one of the cyanide groups. Then you can CN again to denote one of the cyanide groups. Notice one important thing over here is you need to remember that when we talk about such groups, you can't write the bond and write OH like this. This is wrong, okay, because hydrogen's valency is only 1 and it is already bound to the oxygen atom. So oxygen is the one joining the carbon. Similarly over here, actually CN is a group, NC is also a group, also a functional group. That's called as, this is a cyanide, NC is an isocyanide. So when we write it as NC, the meaning is completely lost. So this is wrong. You should write it as CN. The carbon is the one which is bound to the other carbon and not the nitrogen. Question 12.6. Expand each of the following bond line formulas to show all the atoms, including that of carbon as well as hydrogen. So we are asked to basically draw the structural formula. And in the structural formula, all the atoms, including basically all the atoms and their bonds, are visible. So let's start. So first, to help you understand how to convert this to this, I will do it step by step. So here you have hexane, cyclohexane. Okay, so let's write the carbon atoms. So hexane means there will be 6 atoms in this molecule. Now in this carbon is bound to another carbon, this one, and then you have 2 other carbons. So this is the basic structure or the structural formula of this molecule. Now we need to write the hydrogens. Now each atom of carbon has to have valency equals to 4. So let's start from this one. Here this carbon atom is already bound to 2 other atoms of carbon, which means it will bind to 2 atoms of hydrogen. So 1, 2, 3 and 4. Similarly, it's the same for all the atoms except for this one in this cyclohexane part of the molecule. So each of these carbon atoms has 4 other atoms it is bound to. Now in case of this atom of carbon, here it's already bound to 3 atoms, which means it needs just 1 more for the valency to be equal to 4. Same goes for this one. This bound to 2 other, 1, 2, 3, then 4. Now these 2 carbon atoms have only 1 bond each, so they'll be bound to 3 other atoms of hydrogen. So first what we did was we drew the carbon skeleton and then we added the hydrogens because it's easier to do that. If you're more comfortable with doing it directly, you can, but I find that this way you tend to make lesser mistakes. The next one, B. Now 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 atoms of carbon in this molecule. So first let's write down that 3, 4, 5, 6, 7, 8. We know that the terminal carbon atoms are always going to be CH3 unless and until specified. So H, H and H. Here also you have a H, H and a H. Now each of these carbon atoms already have 2 bonds, which means each of these will be attached to 2 other atoms of hydrogen. Here again you have H, H. That's it. The third one, so here that triple bond over there indicates that the 2 carbon atoms have a triple bond between them. Okay, so first let's draw the main chain. So here you have 1, 2, 3, 4 and 5 atoms of carbon. So 1, 2, 3, 4 and 5. Okay, now between the first and the second carbon atom you have a triple bond. So let's put that in. Now the first, second, third, fourth. The fourth carbon atom has undergone, or rather is bound to an OH group. Let me just number this for you. 1, 2, 3, 4. I am not talking about nomenclature. I am not talking in terms of anything. I just randomly numbered it. So the first and between the first and the second, you have a triple bond, and the fourth carbon atom has an OH group attached to it. So 1, 2, 3 and 4. This is the fourth carbon. So you have an OH. Now we need to add up the hydrogen atoms. Here 3 already are done. This is the fourth. 3 plus 1, 4. So it does not have any H atoms. This, however, only has 2 bonds. So it has to have 2 other atoms of hydrogen. This already has 3. This will have 1 more. This is the terminal carbon, which will have 3 atoms of hydrogen. Now the fourth one, D. Now this is the bond line structure. Okay, so 1, 2, 3 and 4. Let's take 1, 2, 3, 4. 4 carbon atoms as the main chain. So 1, 2, 3 and 4. We know that the second and the third atom, the carbon atoms, have a methyl group attached to it. So C and C again. So now we have to fill in the hydrogens. So H, H and H. This atom will also have H, 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 and then H, H. So for us to convert from the bond line formula to the structural formula, what we are doing is we're first writing the basic carbon chain along with the respective functional groups if anything is present. After that, we are putting in the hydrogen atoms, which to ensure that the valency of carbon remains 4. Okay, and one more easy way for us to remember in such straight line structure is that if carbon already has 2 bonds, you already have, you need to add in the 2 others. So that's about it. In the next video, we'll be discussing about the 3-dimensional notation of organic compounds.